Now if we're looking for motion along a line, in this one they give us a function here, and we want to find the velocity acceleration. So in this case, x is the position, and so our velocity would be the derivative of this. And if we wanted to find the critical points for this, find when it's changing direction, we would set that equal to 0. This would then give us zeros of t equals 1 and 11 over 3. Okay, so that would be for our first derivative. Now our starting point would be at 0, but these are our critical points here, and where we might have a change in direction. So if we want to know that if we actually have a change in direction, we need to plug in points that are less than this. Notice if I plug in 0, that's going to give me a positive number. Anything between these is going to give me a negative number, and if I plug anything greater than this, I'm going to get a positive. So we're seeing a minimum, and then, a maximum, and then a minimum, because we're going up, going down, and then going up again. As you can see in this graph, we also see the signs represented in this, our derivative, or actually our velocity graph. Here, our velocity graph. We next want to look at the acceleration for this, and so we're going to take the derivative of the velocity, coming back up to here, which will also set equal to 0 to find inflection points. And so to find our inflection points, those are going to come at 28 over 12, which would simplify to 7 over 3 seconds. Okay, now we can see that represented in this graph here for our acceleration, that before that, and we could plug in values less than t, we're always going to get negative numbers. Greater than 7 over 3, we're going to get positive numbers. And so it's going to tell us that since we're talking about acceleration, that this is going to tell us that our acceleration is actually in a left direction, and this one our acceleration is pulling us in a right direction. So looking at our information here, we can say that we're moving right between 0 and 1, moving left from 1 to 11 over 3, and then moving right again from 11 over 3 to infinity. Now our acceleration, we can think of this as the direction we're going, so we can say maybe that we're decelerating before 7 over 3 and accelerating after that, or they might say the accelerating force is directed toward the left on this time interval and towards the right everywhere after that time. Now another way to think about acceleration or deceleration might be with the term speeding up and slowing down. And to determine if we're speeding up or slowing down, we're actually going to look at the signs of velocity and acceleration. So if I think of this 1 here, splitting this interval in half, the 11 over 3, I'm going to bring it down. I can bring my 7 over 3 up here. I've actually got 4 intervals here to look at. So what we're looking at to decide if we're speeding up is that velocity and acceleration have the same sign. So basically the acceleration is pulling in the same way that we're going. And if we're slowing down, velocity and acceleration have different signs. And so looking up in my table, I'll notice that from 0 to 1 I have different signs, and so on this one I'm slowing down. If I look from 1 to 7 over 3, I have negative and negative, and so we're speeding up. Over the next interval, from 7 over 3 to 11 over 3, you notice I have a negative here, positive here, and so we're slowing down, those different signs there. And then everywhere after that I'm positive, and so we're speeding up from 11 over 3 and on.